By the end of this lesson, we will be able to divide fractions, mixed numbers, and integers. We will do this by reviewing the rules for multiplying. We will also analyze division of integers to try to find patterns. So first, let's just discuss some of these examples. No need to write these down. The meaning of division. So if I had 6 divided by 2, that really means how many 2's can fit into 6. And we're very familiar with a question like this. 2 can go into 6 3 times. 24 divided by 4 means how many 4's can fit into 24. 4 can divide into 24 6 times. Okay, let's look at some that are a little bit more challenging. If I had 9 divided by 2, now we want to know how many 2's can fit into 9. 2 does not divide evenly into 9. We are familiar with dividing using long division. 2 can go into 9 4 times. If I subtract 8, I get a remainder of 1. There are many ways to express this answer. I can say it goes in 4.5 times, or I could say 4.5 times. These are equivalent. Now let's look at some division problems that require, or include rather, a whole number and a rational number. These can be a little bit more confusing. Again, no need to write these down. If I asked, what does 3 divided by a half mean? It's really asking how many halves can fit into 3. So here I have this diagram ready to go. If I have 3 units, but I want to know how many halves will fit into 3, I can cut each of these 3 items in half. Now, how many units do we have? 1, 2, 3, 4, 5, 6. 3 divided by 1/2 then equals 6. I can fit 6 halves into 3. Okay, the next one. 5 divided by 1/3 means how many thirds can fit into 5. So here I have 5 units. We want to know how many thirds can fit. So I can take this single unit and break it into thirds. I can break this unit into thirds, the following unit into thirds, the next 3, and the next one. So now I have 3, 6, 9, 12, 15 total. There are 15 thirds, so 1/3 fits into 5 15 times. Again, let's look at the next one. 6 divided by 1/4 means how many quarters can fit into 6. So if I had 6 units and I broke each into quarters, that would mean I'd have to split this in half and then each half in half again. So if I continue to do this all the way across, hopefully you noticed a pattern. I would have 4 from this unit, another 4 here, 4 quarters here, 4 quarters there, another 4, and another 4. So 4, 8, 12, 16, 20, 24. I would end up with 24 quarters. There's certainly a pattern there. Okay, please copy down the title, Dividing Rational Numbers, because now I'd like you to record example 1, 2/3 divided by 1/6. Okay, there's no reason to copy down these questions in blue, and you should have a copy of this chart to refer to from class. So right now we want to know how many sixths will fit into 2/3. This is much more complicated. So let's use my highlighter tool to take a look. I want to know how many sixths will fit into 2/3. Well, first, let's see how big 2/3 is. There's 1/3. This is 2/3. Okay, so this region represents 2/3. We'd like now to figure out how many sixths can fit into 2/3. I can fit 1, 2, 3, 4. So the answer to this question must be 4. Please record your answer. Now let's move on to number 2. I want to now know, for part 2, 3/4 divided by 1/3. This means how many thirds fit into 3/4. So let's use the diagram on my screen to help figure this out. We need to know how large 3/4 is. So here's 1/4, 2/4, 3/4. So let me shade in this region. And now we want to count up how many thirds can fit into this 3/4. So I can fit, let's see, let's change the color here. I can fit 1/3. I can fit 2/3, but I can't fit this third one, and I'm still not perfectly equal. I still have a fraction of this third. So this is going to equal 2 and then some fractional part. Okay, now we need to investigate our patterns. When dividing fractions, there is a rule that we can always use. You may have used this last year. Please copy down to divide fractions, your title. We need to KCF. KCF stands for keep, change, flip. This means keep the first term, change the division problem to a multiplication problem, and then flip the second number to its reciprocal. Basically, we're using the multiplicative inverse to find the answer. So after you've copied these notes, you just need the keep, change, flip part. We're going to revisit problems 1 and 2 and then move forward. Okay, please find problem 1 in your notes. We've already had the answer. We said 2/3 divided by 1/6 is 4. We can see that 1/6 can fit into 2/3 4 times. But now let's see how we can find this out if we didn't have this useful diagram nearby. The rules are to keep the first fraction. So I'm going to keep 2/3, change the division to a multiplication problem, and then flip this fraction, writing the reciprocal or the multiplicative inverse. And then now we have to multiply and simplify our answers. We can multiply straight across and get 12 divided by 3 times 1 is 3. 12 divided by 3 is 4. We could also, if you noticed ahead of time, reduce. 3 goes into 3 once and into 6 twice. 2 times 2 also takes us to 4. Okay, now find problem 2 in your notes. This is the one we were stuck on. We wanted to figure out how many times 1/3 can fit into 3/4. As we can see below, I can fit 1/3, I can fit 2/3, but then I'm not sure exactly how much of a fractional piece of this 1/3 I can fit. So I know it's going to be 2 and some fractional part. So let's use our new rule. If I keep the first fraction, 3/4, change the second one to a multiplication problem, and then flip the second piece. So I have 3/1. Now let's see if it's close to our prediction of 2 and then some fractional part. Here I have 3 times 3 is 9 over 4 times 1 is 4. This is an improper fraction, so let's change it to a mixed number. 4 goes into 9 2 times, which is 8, and then I'd have 1/4 left over. Let's see if this looks about right. If these pieces were perfectly created, we would see that I can fit 1, 2/3, and then 1/4 of a third. That would be why our answer is 2 1/4. Let's try problem 3 without the diagram. Problem 3 wants to know 5/12 divided by 1/6. A little bit challenging to visualize how many sixths will fit into 5/12. So instead, let's use our rule. We can keep the first fraction, change division to multiplication, and then flip or get our reciprocal for the second fraction, which would be 6/1. Okay, Okay, now I notice right away that 6 and 12 have a common factor. I can divide 6 by 6 once, and 6 goes into 12 twice. I now have 5 times 1 is 5. 2 times 1 in the denominator is 2. This improper fraction can be written as a mixed number. 2 goes into 5 twice, which is 4, so I have a remainder of 1/2, 2 1/2. Let's compare with the diagram below. Let's see, we want to see the size of 5/12. So let's use my highlighter tool. Here's 1, 2, 3, 4, 5/12. And we want to see how many sixths can fit inside. I can fit 1/6, 2/6, and then only a half more. Please copy the title for the last part of the lesson. Now let's take a look at dividing mixed numbers. Before we can keep, change, flip, there's something else we have to do. I could technically keep this. I could change that to multiplication, but how do I flip a mixed number? Think, what could we do first so that then we could keep, change, flip? Hopefully, we were thinking about converting to an improper fraction. So that's exactly what we'll do. To divide mixed numbers, we have to convert to improper fractions first. So let's practice with problem 4. 2 times 2 is 4, plus 1 is 5. So I have 5 halves. I have to keep it a division problem for now because I'm still only converting to improper. I have 3 times 4 is 12, plus 1 is 13 quarters. Now we're at the keep, change, flip part. So let's go forward. I have to keep my 5 halves, change to multiplication, and then flip. I'm going to check and see if there's any common factors that can be reduced. 2 goes into 2 once and into 4 twice. I end up with 5 times 2 is 10 over 13. So my final answer here is 10/13. This would be a great time to pause the video here, try number 5 on your own, and then press play to check. Okay, check to see how you did so far. First, we need an improper fraction. Then we can keep, change, flip. I noticed 3 and 6 had common factors. I divided each by 3. I ended up with 38 over 8. I now see that both of these are even, so I'm going to cut them in half so I can reduce. 8 divided by 2 is 4. 38 divided by 2 is 19. So now, let's see. 4 and 19 have no common factors, so let's change this to a mixed number. 4 can go into 19 4 times, that would be 16, and then that means that there are 3 left over, or 3 remaining, so 4 3/4. Tomorrow in class, you should be able to divide fractions, mixed numbers, and integers. Okay, you should be able to use the same rules we use for multiplying because essentially a division problem becomes multiplying by the reciprocal. Thank you for watching.